Good day. Welcome to the Microsoft Research Summit 2021. I'm here to talk about the nexus between climate change and energy policy, lessons from California. I am Bob Weisenmuller. I am the ex-chair of the California Energy Commission. I'm sure most of you don't know what the Energy Commission is. The Energy Commission was established in 1973 under Governor Reagan, but then implemented in 1974 under Governor Brown. It was pretty far-reaching legislation. It basically put this agency up to develop energy policy, to encourage energy efficiency, to certify power plants over 50 megawatts, to encourage energy innovation, to transform transportation, develop renewable energy, and prepare for energy emergencies. I'm here today to talk really about climate change and then energy policy. And then I'll have a few words at the end just summarizing both. Looking at the climate change part, the basic message is there's no time to wait. That at the Energy Commission, I was appointed as the scientist engineer on the commission, and I've certainly been studying or thinking about climate change for a long time. But the thing that became obvious in 2018 to me was that we're now living it. That was really drawn home to me by visiting Paradise, California, right after the fire. It was like it had been firebombed, literally. And since that time, there's been this basically reaffirmation. The IPCC in last August also concluded, first, that it's code red for humanity, but that climate change is here now, and humans are responsible. In fact, they say that humans have added enough GHG to warm the planet by about 1.5 degrees Celsius. The majority of the warming is tied to carbon dioxide and methane emissions. Now, one of the other things for me that occurred in 2018 was we published the fourth California Climate Change Assessment. That's a multi-agency document, the Energy Commission, Resource Agency, and the Governor's Office. It's about 45 studies that were all done with common assumptions. The basic message from that study was that California is getting hotter and drier. There's a variety of other things, but sea level rise, etc. But the message was that the climate is changing. And if you think about California, it's a very varied state in terms of its climate zones. But the thing that really popped out as a danger from that study was fires. And these data actually started about 1920. And as you could see, looking at the top 20 deadliest, the top 20 most destructive, and the top 20 largest fires in that period of time, they're almost all in the last 10 years. Maybe a few more in the prior 10 years. But it's really been a dramatic increase year by year in the nature of these fires. I mean, in 2018, it was like 400,000 hectares, and last year it was 4 million. So, again, it gives you the sense each year it's sort of worse than the last year, looking at these three criteria. That really gives California a strong motivation to really deal in its energy policy with greenhouse gas emissions. In particular, California has, at this point, 3 different goals for greenhouse gas emissions. The first was actually voted in the 2006 period under Arnold Schwarzenegger, which was to reduce the greenhouse gas emissions to 1990 levels by 2020. Well, we achieved that in 2016, which was really impressive action. The next goal is for 2030, and that's to reduce to 40% below 1990 levels. Again, that's still in progress, so we can talk about the tools that we're using to try to get there. And then the last action of Governor Brown in 2018 was to achieve a zero net carbon economy by 2045, his executive order. I mean, that's really much more of a blank slate at this point. One of the key messages I want everyone to leave with is that one of the things that California has really demonstrated is that it's possible to grow the economy and reduce greenhouse gases emissions at the same time. This particular chart shows you that California's GDP is grown vigorously. I mean, pre-COVID, it was the 5th largest economy in the world. In the 10-year span I was in Sacramento, it went from like the 9th to the 5th. But at the same time, greenhouse gas emissions, either total or per capita or per GDP, went down. So again, it's possible to decouple growth from greenhouse gas emissions. As you think about how to do that, the first context is this is looking at California's inventory of emissions. Obviously, if you look at other states, other countries, or other cities, it's going to be a different inventory, and that will really drive the actions. But for California, the thing that emerges most clearly from this chart is the real action is transportation. If you look at not just direct transportation use, but also indirect, i.e. production of oil and refining, it gets to 52%. So more than half of the emissions in California are transportation. You can also see that just about everything we do in California has some emissions associated with it, be it buildings or power generation or agriculture. So you need a very broad-based program, at least for California, and I suspect for most of the world. So going back to California's goal to reduce greenhouse gas emissions, the basic plan is developed in what's called the scoping plan, and it's to come up with a portfolio of policies. It's required to be updated every 5 years, and the goal is not just greenhouse gas emissions, but also air quality co-benefits. The very first one in 2008 basically came up with, dealt with the issue, was it possible to meet the 2020 target? And the conclusion was it was cost-effective and technologically feasible pathways. 2014, we obviously examined the 2020 target and also short-lived climate pollutant plans. I served as the chair of the Energy Commission from 2011 to 2019, so I was part of that process in 2017. In 2017, that then became the question of, well, how do we do a cost-effective and technological approach to achieve the 2030 target? Now, I did mention the zero net carbon goal in 2018, so that's going to be the real center point of the 2022 scoping plan, and frankly, workshops have just started on that, but it'll be a two-phase. One is to look at progress on 2030 and see if what we need to do in addition, or if we're on a pathway, and then to start mapping out 2045. This, again, is the 2017 version of that overall policy portfolio. I'm going to talk primarily about the energy part today. So the first tool was doubling building efficiency. Now, California has been working on building efficiency since the 1970s, pretty effective. So this is a real stretch goal. Renewable power moving to 50%. Since then, the legislature has amended that to 60% by 2030 and 100% by 2045. And obviously moving towards cleaner zero or near zero emissions for cars, trucks, and buses. There's a lot of other associated policies there on transportation, as you would anticipate, but I would also note that there were some policies put in place to deal with super pollutants like methane, in terms of dairies, landfills, and refrigerants, and also some policies to start protecting and managing natural and working lands. California, again, transportation is really the dominant problem. We have about 28 million cars. We have about 1 million trucks. Not only does that dominate greenhouse gas emissions, but also air quality. I mean, 83% of the criteria pollutants in California are from transportation. We have severe non-attainment areas in the Los Angeles area and also in the Central Valley. And we have an enormous level of petroleum consumption. 14.5 billion gallons of gasoline, 3.6 billion gallons of diesel. Our basic strategy is first to reduce the demand and then step down the production of petroleum in lockstep, as opposed to trying to basically reduce petroleum production and while not discovering we haven't reduced demand. In terms of how are we going to do that, zero-emission vehicles is really the cornerstone. And zero-emission vehicles, you really have a chicken and egg problem. One of the things you need are chargers, and that was the Energy Commission's responsibility. Well, no one's going to build a charger or refueling station if there are no vehicles that could use it. And similarly, no one's going to buy a vehicle that needs to be recharged if there aren't any charging infrastructure in place or refueling in place. So you have to build those together. I guess looking at what I call the bottom line, California now has about 600,000 plug-in electric vehicles, and about 6,300 of hydrogen fuel cells. That, in terms of the plug-in electric vehicles, that's a little under 50% of the electric vehicles in the U.S. In terms of the charging infrastructure, again, we know we need a lot more, but we are making progress there, and we have pretty aggressive goals by 2025. I would point to the other real takeaway is Governor Newsom really recently set the goal of 100% of in-state sales of all new passenger cars and trucks to be zero emission by 2035. And to again re-show the commitment there, within the last month, the legislature appropriated and the governor signed an additional $3.9 billion to be spent on zero-emission vehicles over the next 5 years. To, again, re-cement California's leading role in that area. There are a couple of other policies associated with this, and again, I'll give you a brief overview. One is something called the Low Carbon Fuel Standard. And what that requires, if you're selling a mix of fuels in California, you have to meet a carbon intensity standard. And there's trading around that to meet that, so basically it results in payments to very clean fuels from more expensive ones. The other thing is the corporate average fuel economy, or CAFE standards. We have done CAFE standards for years, and that basically requires fleets to achieve a certain level of fuel economy. Originally, that was very focused on pollution, and at the same time, at this point, obviously, CO2 is a pollutant, so that's probably at this point, it's much more the driver on our CAFE standards. Obviously, we've had some back and forth with Trump on whether we continue to do this. That's all been resolved, we hope. And the other thing that's really a key driver in transportation policy is most of the goods from China to the U.S. come in through either the Long Beach or Los Angeles harbors. And then they move through Los Angeles to warehouses, in some of the outlying counties like Riverside. And from there, the goods are broken up and they go by trucks or train basically to every county in the U.S., which means there's an enormous amount of pollution from goods movement in the South Coast, and at the same time, it has a substantial economic benefit. Now, there's also a push towards shore power at the ports for the boats bringing in those goods. So again, the whole goods movement, into Los Angeles, through Los Angeles, and then through the rest of the country is certainly an area that needs to be electrified. One of the overall policies for California is something called cap and trade. Now, people often talk about a carbon tax. And what a carbon tax does is you put a price on greenhouse gas emissions, and you know the price, but you don't know the impact of that price on the various emissions. With a cap and trade system, you put a cap on the total emissions, and then you require trading or payments to basically meet that standard. So here you know the economic impact, or you know the impact, on the overall emissions, but you have less understanding of the economic impact. California, this is economy-wide, more or less, and with the cap and trade, some of it's rebated from, say, to the utilities, so it goes back to their customers, and other parts, where basically people are buying credits. That then generates income, which can be then used for California's climate investments, and it's a substantial amount of income. and we also target about half of that towards disadvantaged communities. The other, switching now to the grid, our big target there is both renewables and energy efficiency. So looking at the renewable part, as you can tell, in the last 10 years, California has had a substantial increase in solar and wind. In terms of solar, that's shown there in terms of behind the meter, which basically reflects Governor Schwarzenegger's 1 million solar homes goal, which we met last year, and utility scale solar. So that's really been the big growth area. Wind there is primarily, it's just onshore. And you can see the geothermal, small hydro, and biomass are pretty flat. Now, California does not include large hydro in its definition of renewables, but we have a substantial amount. The notion was to use what we have, but not to encourage any more large hydro. So once you add up this, or what we define as renewables, and there are many countries or states that would include large hydro in their definition. So when you're comparing, you have to keep that in mind. Also, we have some nuclear power still in California. We're down to about 37% of the grid is supplied by basically fossil fuels, mostly natural gas. One thing to just talk about in the renewable context, there's a lot of concern about, we obviously are very heavily based on intermittent renewables. If you going back for just a second here, the solar and wind are quote-unquote intermittent, which means you can't control when they come. And this, again, gives you the demonstration of that. Obviously, the solar, and this is looking at basically a day last month that I just randomly picked out. That solar peaks at around noon, and it comes up rapidly as the sun rises, and it falls rapidly as the sun sets. And that means that you really, looking at the right, you really have to push out of the way basically fossil fuel, mostly gas generation in California, and imports to be able to use as much of that solar as you can. And then as you move towards the sun setting, you have to then ramp up as much as you can the gas units and the imports to basically keep the lights on. And, we're talking about that evening peak, so it's, loads, resources are going down while loads are going up is the bottom line. And so that's one of the things which, we've had some reliability issues on, because obviously as you're scrambling to deal with like a 14,000 megawatt ramp, then if you have a power plant trip off or if you have a transmission issue, you're scrambling. And certainly our Cal ISO is becoming good at scrambling, but it's challenging. We expect over time, one of the key things that will help are batteries. The other thing is demand flexibility, which I'll get to in a second. So this shows you batteries. I mean, battery costs have come down almost 90% since 2010. And as they've been driven down or pulled down by the demand for basically zero-emission vehicles. Primarily, transportation has really been the driver for transportation, driver and transportation for development of batteries. Now, as the costs come down, you also use batteries, in the grid. You can use it in your buildings. In fact, California did goals in 2010 to encourage utilities to buy storage, and they basically split that between the grid and distributed storage behind the meter. So, bottom line, though, this has been a real opportunity in the grid, and California now has the largest single power plant it's all batteries. The other big thing that California has always done is energy efficiency, and this just shows, since Governor Brown in the 70s was California's youngest governor, and I worked with him then as a staffer on the Energy Commission, while in more recent years he's been the oldest governor, and I was chair of the Energy Commission. But this shows the impacts of the policies we developed in the 70s on really helping California's energy efficiency by affecting electricity demand. Looking at the tools we've used, and again I'm going to do these at a very quick level, one thing has been building energy efficiency standards for new construction. And again, the thing I want to highlight in 2019 is we required photovoltaics for all low-rise residential to meet basically their baseline electrical demand. There's some footnotes there. Obviously, if you're building under a tree, we understand we got to do some workarounds. Well, 2022, which were recently adopted, also expand to that solar PV requirement to non-residential buildings and include storage as part of the requirement. Now, in all cases, we're starting to shift the standards from simply looking at energy efficiency to also looking at basically electrification. Most of California's buildings were gas, and at this point we're trying to encourage new construction to shift more towards heat pumps. And the last note indicates that one of the things we're doing is requiring the builders to make sure that everything's electric ready under the presumption that at some point you will shift from gas to electricity for heating, and space and water, and also for cooking. We also have appliance standards. Now both, and we've done these again since the 70s, both of these must be cost effective over the life of the consumer product. And that somewhat more at the beginning, and obviously by the end savings to compensate for that. One of just a couple of interesting things here is in California, the nexus between water consumption and energy use is so tight, we actually can regulate the water consumption of appliances based upon their energy usage, which we do. We are preempted by the federal government where they have existing standards on products, and there's a recent law that basically requires the CEC to look at building demand flexibility into appliances, and that would be another way of complementing the intermittent renewables. So now I just want to talk about lessons learned. California has demonstrated, again, it's possible to both grow the economy and decrease carbon emissions. California has also shown that energy efficiency can be used to flatten basically energy use. The obviously increased renewables energy efficiency allow you to reduce greenhouse gas emissions and air quality emissions for the power grid. We've done a lot of activity on electrification, but frankly our transportation programs are lagging in achieving our goals, and in terms of having major reductions. And also just in terms of, with the wildfires now, that's really complicating the situation because that's adding more emissions and obviously more air quality impacts. So we're going to need further innovation to achieve the net zero economy by 2045. Looking at what I would consider some of the outstanding issues, first, the GHG inventory we have is sort of the things the ARB historically has regulated. So it doesn't include wildfires, it doesn't include natural working lands. And so the question becomes, how would your pathways change if you had a more comprehensive inventory? And one of the suppositions is you have to focus more on some sort of carbon capture. Wildfires keep getting worse. I mean, that's the other thing that would become obvious as you build that into the inventory. And so what are our mitigation measures? At this point, one of the mitigation measures is these power shutoffs. And again, that's not the way to go forward over the longer term, particularly as you're encouraging electrification. As I said, we had a pretty impressive climate assessment, and we're starting the fifth one. But California has really a variety of ecosystems and climate zones, and climate science is really evolving. So I can't say we really understand all the cumulative impacts, but we are definitely motivated. What's the optimal pathway to get to zero net carbon by 2045? Can it be accelerated to, say, 2035? Storage has been a real game changer for transportation in the grid, but we still have some issues there. One is safety issues on the lithium-ion batteries, and the other is that batteries are good for about 4, maybe 8-hour storage periods. We need longer-term storage, week, maybe 2. So we need a mix of new technologies. How can we electrify everything without grid issues? And again, I'm sort of a physical science background, so a lot of this talks about the physical questions of societal dimensions of the transition. Talking about the physical, but the real issue is what are all the societal dimensions of this? And for example, what are the impacts on environmental justice of this transition? Again, I'd like to really thank everyone for their attention today. And any questions, you can also email me those. Thank you.